Hello guys, just received this job to do a FEA test on a clamp. I'm going to show you how to do that from importing the file to um, hyperworks. So let's click SolidWorks. It's a CAD file, so we have to change that. Click open. This is the clamp. Open that, and you want to save this as IGS or IGES file. I already saved it, so I'm not going to save it again. I'm just going to cancel it and then close SolidWorks. And once you open HyperWorks, uh, select OptiStruct. That's the solver for static analysis. Select OK. And we're going to import that file. Initially, you're going to see a blank space like this. Then click Component, this guy, and select the folder in which you save the file. It's here, this guy. Select Open, and then Import. See, this is the component. Select Close. Um, um, so it's 1018 miles still. So first we want to define the property, the material first. Material name, let's enter 1018 steel. Select the color, type isotropic, and this is gonna be mat 1. Then create edit. This is gonna be the properties of 1018 steel. They're typical for steel, so you don't have to change them. Select return and select return. It's already being created over here. Now we're gonna select properties. First, I'll show you how to mesh the thing using 2D and see how the results turn out. So we're gonna go to 2D and auto mesh, and then select all. Actually, no. Go back to return, 2D and auto mesh, and just surface. Select surface. Then we can select this surface first, and then you can. I'm going to change the element type to quarks. That means rectangle. The size will be 0.1, and you can merge that. Hard to see. Yeah, it's like that. Looks okay. Select return. Select the top surface. The same properties. Select mesh. click return. The back, select mesh, click return. It's better to use this one. Just click this, hard to see. So now we're going to select the side surface and click mesh. You can see there's a lot of distortion over here. We can fix that by splitting the surface into a lot of pieces. That way we can mesh better. We're gonna reject and we're gonna return and return again. Go to geometry, click edit, select split surface and line, click node. There's gonna be a node, then line, you click this this line, split this surface in two. Do the same thing over here. Just going to connect them. Okay, do the same thing to the other side too. Select return. And then go to the auto mesh and then just select them, just click unmesh and then just mesh them all. That everything looks okay. You may want to take a look at the hole over here. You can see some distortion, and for our purposes I think this mesh is fine. We're looking more specifically for the reaction of the junction over here, not the around the hole or on the surface. So I think the mesh is fine. Click return. Click return. Okay, turn off the solid geometry. You can see the mesh right now. To do the we need to import, to do the test we need to import the properties. Just say clamp, change the color, type is gonna be 2D, material gonna be steel, create edit, click return. Just delete this first. go to properties, click create clamp color type. You want to select 2D material steel and create and edit. Select return and click component, click update, click this and select no properties, select the property you just created and update edit. Click return. You can see it's the material and the clamp, the property have been assigned to the component. Now we want to select low collector, select typing constraints, go to analysis, click constraints, nodes, turn off the so I know this surface gonna be fixed, so just select one of the nodes on the surface, then click this, click by face. It's gonna give you all the nodes that's on the surface. We wanna deselect these nodes. Okay, and click since all the direction and rotation are fixed, just check all of this, select create, select return. Okay, now we're gonna create another low character. This is gonna be our forces. Select create, change the color to yellow, create, select forces, the forces are going to be on this surface. Click nodes, just select all these nodes. When you select, you want to count how many you have selected. And then let me see, the forces is 1,400 pounds. I have converted 1,400 pounds to newtons, and I need to do a calculation. Six 28 divided by 22. That's the force on each node, 283.1. Magnitude is gonna be 283.1. The direction will be in the y direction, positive. Click create. The forces have been created. Select return and go to load steps. Typing name, clamp, test. Make sure you have linear static. Select SPC will be constraints, load will be forces, and create. And then you're ready for the, before that, select all, this is select all in this analysis. Before that, you might want to save as model. You can just create a new, okay, now analysis, uh, click OptiStruct, so return, oh, you gotta select shell, car image, select shell, and update added, and thickness should be 0.1, click return, and return, that should be alright. Do the same thing, select yes, analysis completed, click close, and go to this view, just click on it, it will guide you to select, um, go to work, go to select H3D, go to apply. See, this is where the trouble that I encountered with 2D meshing. We can go to the beginning. Uh, uh, I thought it was fine to create 2D. I don't know. I guess I was wrong. And the forces are too big, and 2D meshing really reduce the strength, so the component yields terribly. See, it's deformed like crazy. You can click this and see the displacement. Click apply. You can see the displacement is almost 100 millimeters. That's terrible. I don't understand. The forces are supposed to be pointing in the y direction, and maybe because of the constraints, the forces somehow change the direction. The structure changed the direction. The force is still along the axis of this. We can also check the stresses. Click apply, and the maximum stress happens at the junction over here, and it's at 1.62. That's almost 1,600 megapascal. The use strength of the 1018 steel is 370 megapascal, so it's like almost 5 times of, no, 4 times of the yield strength, the maximum stress. So this is the problem with 2D meshing for this particular job. I'm going to try solving the same problem with 3D meshing.